So going over the answers to the chart guide. Number 1, it's asking about the equation of this graph. Oh, okay. The line may have gotten. I don't know if I can because I think it was. I think it was line like more. Right. So then your equation of your line would be y equals negative 2 over 3x plus 1. Number 2, you have to find the slope. So if you subtract 3 minus 3 over negative 3 minus 4, you get 0 over negative 7, which is just 0. Number 3, we haven't talked about, but you may remember this from algebra. Here you are simplifying exponents, so your exponent rules come into play. If you are dividing just numbers, you're going to just simplify those. If you're dividing like bases, like these both have C's, these both have D's, then you're actually subtracting the exponents. So this would be C to the 5th and D to the negative 4th. And then another couple exponent rules come into play. Anytime you have a negative exponent, you really take that, flip it so it's 1 over D, and raise it to a positive exponent. It's just your negative exponent rule. And then combine everything so it's one condensed fraction. So when you do all of those things, you get C to the 5th over 9D to the 4th. Number 4, you have to combine like terms. So when you do all of that, combine all of your x's and your constants, you get 12x minus 14. And the last one was going back to your inequalities. We were given x is greater than 1. So if you remember your Poisson, x is a vertical line. This does not have the inequality underneath it, or the equal to underneath it, so this would be a dashed line. And then everything greater than 1 would be everything to the right, so this would be shaded to the right. Questions on any of these 5?
Several, but like the 4.
Did you want to ask them?
I mean, I just don't get any of what you just said, so like, it was like 10 examples, so like, it's cool.
It's practicing but today what we're going to do is finish the notes, the last set of notes we worked on, which was like a couple weeks ago, the ones that look like these, where we were finding the parent function and seeing all the different transformations that applied with those. Take those out. If you don't have those, I do have extras here on my desk. So I said, look for those first, and if you don't have them, raise your hand, I'll bring them to you. Want to say we got through the first 2 pages, and we're going to start on this page. So we'll do a little of this before lunch, and then we'll pick this back up after lunch. A lot of this is going to be a summary / review of all of this stuff, which is good because it's been a couple weeks since we touched all of this. Before we do any of that, I do want you to write this somewhere at the top. These two equations. So f of x equals a times x minus h in parentheses squared plus k. And f of x equals a times the absolute value of x minus h plus k. So the quadratic one should look familiar because we've talked briefly about that when we were doing quadratics. That's the vertex form, and you can easily find the vertex when it's in that form. We're going to be using that from that one and talking about how these relate to those. For vertical and horizontal, talking about those a little bit, we know vertical is up and down, so I'm just going to draw an arrow to represent that. When we do anything vertical, it affects your y values. And anytime we have something vertical, this is usually on the outside. So like your k value, your a value, those are outside things. So those would be vertical transformations. And then when we talk about horizontal things, they're like the opposite of all these. So horizontal is left and right. These affect your x values. And these are usually anything on the inside. So like your h is kind of negative inside. Anything inside is horizontal. Okay. The next part of this, I'm going to kind of talk about how these transformations relate to the functions given to vertical and horizontal, and give a visual too. So the first thing I'm going to do with all of these is draw in two sets of axes. Because for each of these, I'm going to show the vertical and the horizontal of all of these. These are going to be rough sketches, so they don't have to be perfect. And then we're going to draw in the parent function. Let's say we're just using the quadratic just as an example. The parent function would start at your origin in the center and just kind of go up. It doesn't have to be exactly the parent function as long as it looks the same. You're going to draw that on all of your axes. If you want to go ahead and label them all as V and H, you can do that. You don't have to do that. It may help you to do that. So if we have a vertical translation, vertical is up and down, so it can either be moved up or it can be moved down. So I know mine are in different colors and yours are with pencils. Just draw the same thing so that you know it went up and it went down. Anytime we have a vertical translation, that's your plus k or minus k in your function. Sorry. Your horizontal translation is left and right. So it can either be moved somewhere over here or moved somewhere over here. And that's your h on the inside, minus h on the inside, where whatever that is really opposite of whatever you think. So if it says minus, you're really moving to the right. If it says plus, you're really moving to the left. Whereas your k, whatever it says, is what you're doing. Your vertical reflection flips over your x-axis. Still starts at the origin, but it's upside down. And that's when your a is negative, your a value in front. Your horizontal reflection is a reflection over the y-axis, but unless it's moved, you don't really see that. So I'm just going to draw this over top of this. You have to draw arrows like this. Flips like this. And if we were to see a horizontal reflection, your x would be negative on the inside. We've talked about vertical stretches and compressions, but not really horizontal. I will show you what those look like, but we're not really going to deal with a whole lot of horizontal stretches and compressions in this class. We will in Algebra 2. So if we are vertically stretching something, we know it gets narrower. What it's really doing is stretching towards the y-axis. I'm going to write that as a note out here. Stretch toward y-axis. And anytime we have a vertical stretch, your a value is going to be greater than 1. It'll be some number bigger than 1. That's not including the negative. So think about the negative as something separate. So if you have like -5, your a value is still 5, but you're also making it negative. So it would still be stretched. It would also be reflected. So do horizontal stretch and then we'll stop. Horizontal stretch catches similar but not at the same time. This gets wider because this is stretching out towards the x-axis. And we won't really talk about this symbol because we didn't include that in our vertex form. So when we come back, we'll talk about the compressions and then do some examples. For vertical compression, we know that it's wider. It kind of looks like a horizontal stretch, but they are two different things. This is when your a is a fraction, so I'm going to write this like that. 0 is less than a, which is less than 1. It has to fall within that. Your a value has to fall between 0 and 1, so it has to be some sort of fraction. And this would be whenever we have a vertical compression, it's shrinking away from the y-axis, which is why it's getting wider. Yes, cancel page shrink. Cover. And then horizontal compression shrinks away from the x-axis, so this gets narrowed. So I said when you think of those two things, think of what it's doing. Stretching towards the y or x-axis, shrinking away from the x or y-axis. Okay. And then we talked about this at the beginning of this, but all of your vertical transformations would be something that happens outside, so outside, 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 outside. All of your horizontal would be something that happens inside. So now we're going to be given different transformation descriptions, and we have to use those descriptions to write out the equation of what are we doing. So for this example number 1, it tells us we're going to be using our parent function x squared. Translated 4 units down. Is that vertical or horizontal? Vertical. Vertical. So if it's vertical, is that inside or outside? Outside. Outside. So we know this is going to be a vertical transformation outside. I'm just going to write that this is outside so we know where it goes. If you want to write that it's vertical, you could do that too. And then if we were to write translated down 4 units, how would we write the stack part? Using our K or H or A, whatever it might be. -4, not the X part, just -4. This is going to help us start to realize, okay, anytime I see this, this is what I do. Anytime I see this, this is what I do. 2 units to the right, is that horizontal or vertical? Horizontal. Horizontal, which means it's inside or outside? Inside. 2 units to the right, how would we write that? -2. But on the inside. So now that we have all of our transformations and we know how we're going to write them, now we can put those together. So we're going to have our original parent function, f of x. Anything on the inside is going to go in parentheses. So we're going to have this transformation inside x -2. And then all of this is still being squared because our parent function is x squared. And on the outside, we have this -4. So we've taken those transformations that they gave us and rewrote it to make an equation. Have questions on any of that before we do another? Example 2. Reflected over the x-axis. Is that vertical or horizontal? Vertical. And you may need to either go back to the pictures, look at which one is reflected over the x-axis, or think about it. So that would be vertical, so that means it's going to be inside or outside? Outside. And when we have that reflection, that just means something is going to be negative. So on the outside, we're going to have a negative. Translated 7 units to the left, inside or outside? Inside because it's horizontal. Seven units to the left, how would we write that? plus 7. So we have on the outside this negative, f of x equals, on the inside we have this plus 7, so we need our parentheses again. And we have plus 7. And all of that's being squared. What questions do we have on that one? Okay. Now we're changing the parent function. Now it's absolute value instead of x squared. Compress vertically by, oh, these should be switched. This is stretch and this is compressed. Those were typos. It's nice with compressions and stretches because they tell you whether it's vertical or horizontal. You don't have to guess. So then that kind of helps you determine is it inside or outside. So stretch vertically by a scale of 4, inside or outside? Outside. It tells you what the scale factor is, that 4, that's not something you have to guess on this part. So that would mean your A value is 4. So when we write this, we're just going to put 4. Reflected over the y-axis. Is that horizontal or vertical? Reflected over the y-axis. This would be horizontal. So this would be inside. So we'd have a negative x on the inside. Now, we were using parentheses before because of the x squared. Because of the absolute value, we don't really need parentheses. We could just put it inside of that. So our function would be f of x equals, our a needs to go on the outside in the front. So that's where our 4 would go. And then we have our absolute value sign, x, reflected over the y-axis, so we have negative x. If you wanted to, you could put it in parentheses. That wouldn't really change anything. Those would be the exact same thing. What questions do we have on that one? And then compress vertically by a scale of 1/2. Is that inside or outside? Outside, because it's vertical. Again, it tells you what your scale factor is. So your A is going to be 1/2. Translated up 14 units. Is that inside or outside? Outside, because it's up, so it's vertical. And up 14 units, how would we write that? Plus 14. So when we write this, we're not going to have like really anything on the inside, and that happens sometimes. Sometimes you only have things on the inside and not outside. It just depends. We have f of x equals our a value on the outside, so 1/2. our absolute value of x, our parent function, with nothing on the inside, and then plus 14 on the outside. What questions do we have on that one? So I'm going to give you guys practice. There are a lot of things on this. You are welcome to try all of these, but I really just need you to do 9 through 13, the top section of this. And then we'll go over this towards the end of class. Yeah. So focus on just 9 through 13. You are welcome to try the others if you so choose. And we'll go over that towards the end of class. I'm just going to read off these. I know 9 was already done for you. Did anyone have questions on 9? For 10, this should have been y equals or f of x. You can write that however you want. Y equals x squared minus 6. Or if you put parentheses just around the x, that was fine. But everything shouldn't be in parentheses. Number 11, y equals or f of x equals, all in parentheses, x plus 4, and then squared on the outside. 12 was y equals or f of x equals negative x squared minus 2. And then 13 was y equals or f of x equals negative, then in parentheses, x minus 3, and then outside of that squared. If you have questions on any of those, not sure about something, want to check something, clarify something. So next class, we're going to be talking about how to write these equations, but when given a graph. So we'll be talking about the transformations again, but how they moved and reflected and stretched and compressed on a graph and be able to write the equation.